Hello guys, in this video I'm going to show how to solve minimum meeting rooms problem. So given a list of intervals representing the start and end time of n meetings, find the minimum number of rooms required to hold all the meetings. So we have a list of meetings, right? There are 4 meetings in total, which is in a arbitrary order. So should return 2 for the minimum number of rooms required to hold meetings, right? So in order to see it clearly, we should I think we should make a diagram here of basic, right? So the first meeting, let's say the first meeting is 4 and 5, but for these kind of problems where you um, where you go, where you're given a list of intervals in arbitrary order, mm, and it has something to do with intervals overlapping. We probably want to uh, sort the meetings, right? The intervals in start time, right? So after sorting start time, we have uh, 2 and 3 first. The next one is 2 and 4. Next one, next largest start time is 3, then 4. So it should be 3 and 5 first. Then 4 and 5. Right? So here is intervals that is sorted by start time in ascending order. So we will put these intervals into our diagram. Right? First is 2 to 3. Okay. Next one is 2 to 4. Next one 3 to 5 and 4 to 5. Right. So as you can see, as you can clearly see, here the visual representations of all the meetings, right? So come back to our original questions. What is the minimum rooms required to hold all the meetings? Right, we have 4 meetings. And what are the observations that we can make here is probably cannot uh, we cannot use single room to hold 2 meetings that overlap, right? So for example, if we consider only only 2 meetings, let's forget about this for now, right? If we consider these only 2 meetings, then it is pretty clear that we must use 2 separate rooms for each meeting, right? If they overlap, right? They happens at the same time. So we must use two rooms, right? So I think that's very important observations we can make here. So let's see the explanations from the example. We need one room for 2, 3, and 2, 3, and 3, 5. This one and this one. Why is that? We need to use one room for these two because they don't overlap, right? Because they don't overlap, so we just uh, we just put one meeting into the room, and when a tree here, this meeting end, after this meeting end, we will put this meeting into the the previous room, right? The that room. Same for here. 2 and 4 and 4 and 5 don't overlap, right? So after 2 and 4 and sorry, we first put 2 and 4 into one room, and after it ends 4, we put this meeting 4 to 5 to the same room, right? So in total we need only 2 rooms, right? So the idea here is that at any given point in time, we want to know how many um, how many meetings are happening, right, concurrently. So for example, at 2, how many meetings are happening at this time? There are 2 right here. This one and this one, it all start at 2. And let's see, at 3, let's move on to 3. At 3, how many uh, sorry, uh, at 2, because there are 2 meetings are happening, so we need only one room, right? Sorry, because it's happening at the same time, we need 2 rooms, not one room. So at 3, which is the uh, next point. So at 3, how many meetings are happening at 3? So as you can see, the first interval here, 2, 3, have has already ended here. So at 3 is only this one and this one is happening at the same time, right? So the because there's only 2 meetings happening at the same time, so we still need 2 rooms, right? We still need 2 rooms. The next The next point will be for same as previous. One interval ended here, which is this one, 2 to 4 ended. Then how many intervals are happening at 4? We still have two intervals, which is 3 to 5 and 4 to 5. Right, so we have two intervals happening at the same time, and we still need two separate rooms. But what if at a given point in time there are, for example, 4 meetings happening at the same time? Then in those cases we need 4 rooms, right? So the idea here is that we can start iterating to we can start iterating from this sort of intervals, right? We start at the head here, and we check the end time of the current one, and we probably want to know how many meetings are happening at the time that current interval starts, right? And the number of concurrently happening intervals will be the room that we need, right? So, in order to keep track of the meetings that are happening concurrently, we can use a data structure, which is can we use an array here? Is it good enough to use an array to keep track of the meetings? Like, let's say, for example, we have A and B. Let's say A, B, C is the other meetings that happening at the same time. So probably we need 3 rooms for these 3 meetings, right? Each room for 1 meeting. And the next one to consider is D. So if we're looking at D, which is the next meeting to consider, we want to probably form a new set of intervals that are happening when these start, right? So when these start, so it could be the case that we want to remove the intervals that have ended at the time these start, right? So how to effectively take out the intervals that have already ended at the time one interval start. So one data structure that is very good at um, extracting out um, element out of a set of elements is a heap, right? We probably want to take out the one, we want to check the one with the smallest n time first, right? Because the one with smallest n time who has the high chances of being taken out, right? So here we could use what is we could use a min heap, right? We can use min heap based on n time here, right? We want to know that among these intervals, what is the interval with smallest n time, right? So we want to start uh, taking out the has intervals that have ended, right? Okay, so it's enough for explanations. Let's dive in coding now. Okay, so we need to first start. We need to sort the intervals input, right? Based on start time. I want to sort the meeting first. I want to sort it. Taking A and B. A and B are two intervals. So A and B is just start time and end time. So I want to sort by sort time. So I will compare the start time, which is index 0. A minus B will have us will have it sorted in ascending order. Okay. The next thing I want to do here is to just loop over to iterate through the meetings that has already been sorted. Meetings let meeting and of meetings we use for loop. I can destructure it into start time and end time here. Right? Start time and end time of current meeting. Actually, we can do it here so that we can have access to meetings. Then destructure it into start time and end time. Okay, for the current meetings, right? We are consider current meeting. We want to know that at the time that the current meeting starts, how many intervals are still are still happening at that time. So I want to ask questions. How many meetings are happening at the time current meeting start? So we can compare the start time of meeting, right? I can use a while loop here to extract out all the meetings that have already ended. So I can use while loop here. I can compare um, current meetings, no, current meeting start time. I can compare start time here, right? Is greater than or equal uh, to the peak. Okay, we forgot here. This we need to create a heap to store the concurrently con concurrent meeting is a heap. We need to import heap here. Require collection heap. Okay, so it's initially it's empty, and I will give it a hint so that the heap is a min heap based on end time. So because it's a min heap, so b it will be b minus a, but not b, but the end time, which is index 1. A is index 1. So here with the min heap based on end time. So here I want to compare the start time of the current meeting with the meeting in this heap, the peak, right? The peak meeting, which is the one with smallest end time. Smallest end time. So probably it can be the case that the current meeting is empty. So I only want to do this check if the current we have uh, we have non-zero meetings, right? Okay, if the start time is greater than or equal to the smallest end time meeting, then it means we can go ahead and take this uh, the meeting at the top out because it has already ended at the time the current meeting start. Okay, so I will take it out for meeting dot pop. So it will be this one will be this will run as long as this is true, right? We just take it out when it comes here, it mean that we can add the meeting to the heap, right? Concurrent meeting, add, and here and now all the meetings that is inside concurrent meetings are happening at the same time, right? Because we have already removed all the meetings that have ended at the time of the meeting starts, right? So now we want to keep track of the largest, the amount of the number of rooms that we need to hold concurrent meetings, right? So let's say number of rooms. We want to update over time so that we want to update over time, right? So for each iteration, when it comes here, we want to check how many concurrent meetings now. Concurrent meetings are happening now, and that is also the number of rooms as well. So here I can use number of rooms will be the maximum value of current number of rooms and the size of concurrent meetings, right? And at the end, I'll return number of rooms. Okay, let's run the test. Yes, 4 and 5. Probably we don't need this one here. Okay, it works. Perfect. Just to double check. Okay, that is awesome. So it is it for today with minimum meeting rooms problem. So thanks for watching. See you in the next video.